So we were discussing hot working, right? So if you are deforming the material plastically at a temperature above the recrystallization temperature, then we call it hot working, right? So that's the key difference with the reference to recrystallization temperature. We'll see whether we are hot working or cold working, right? The notable points are there is no strain hardening here. Why? Because the temperature is so high, right? That the resistance offered is less, and therefore the dislocations are less. So even though there is strain, but there is no strain hardening because of the fact that the material has become softened, right? The crystals are, I mean, because you are working above the recrystallization temperature, the resistance offered is, I mean, there's no resistance offered, so no strain hardening, right? It will not harden, but it will allow for it to be deformed, plastically deformed. Usually performed at elevated temperatures, right? Lead and tin are exceptions because they're having low melting point. Lower limit of the hot working temperature is 60% of the melting temperature, right? If the melting temperature is, let's say, 100, then 60 degrees is the lower limit for the hot working, below which, I mean, you will be you will not be under the domain of hot working, right? That's what is meant, that at least 60% of the melting temperature you have to maintain. So now what is recrystallization temperature? As I said, the crystals are forming again, recrystallization, right? The temperature at which atomic mobility can repair the damage caused by the working process is an alternative definition, you can say. Because what is happening upon reforming of the crystals is that the atomic mobility, right, the temperature at which the atomic mobility can repair the damage caused by the working process. So if, for example, you have worked on, you have increased the temperature of the material. Now there is atomic mobility, right? Atoms are moving. They are, what do you call, they have increased, they have received some energy, right, in the form of heat energy. So there is atomic mobility. That is what is repairing the damage caused by the working process, right? Because this is actually talking about when you have when you did some process, some cold working process you have done, and now you want to repair the damage. How do you do that? You take it to a temperature and maintain it at that temperature, right? Usually the temperature that is maintained is recrystallization temperature. That is why we are saying that the temperature at which atomic mobility can repair the damage caused by the working process. That is what is your recrystallization temperature. So you see that recrystallization temperature for different metals are given. Lead 10 degrees centigrade. This is below room temperature, right? So this is why we are saying this cannot be done under hot working because of the low recrystallization temperature and the melting temperature, of course. Zinc is having recrystallization as 25, magnesium and aluminum around 150, gold, copper, and silver around 200, iron, low alloy steel 415, tungsten 1400, right? So as the you can say either the density or basically the density, right, and also the bonds, right, the bond structure. That is what will decide the strength of the material, right, and therefore the recrystallization of the material. Basically the melting point is what will be seen to decide the recrystallization temperature, right? You know what is the recrystallization temperature. So tungsten is having the highest recrystallization temperature because its melting point is higher. Now the mechanism for hot working, there is no strengthening occurring during hot working, right? It's not receiving much strength. Unlike cold working, it will receive some strength, right? But here in hot working, there is no strengthening occurring, right? It is not becoming hardened. So no strengthening occurs. Elimination of imperfections. How? Gas pores can be closed. Composition differences can be reduced. With hot working, we are trying to, the gas pores can be closed, and therefore that counts as an imperfection, right? Can be eliminated. Composition differences also can be, because if there are different compositions, they have not mixed properly, then this hot working process will be responsible for mixing those different compositions. Anisotropic behavior is gained. Surface has a finer grain size than the center. So the behavior of the metal is different at different regions. So he's saying at the surface it has a finer grain structure, and at the center you have coarse grain structure, right? So because of the difference of melting, difference of solidifying, you will have this anisotropic behavior, right? Which is desirable in some cases and not so desirable, right? So that is one characteristic of hot working. And the other is metal remains soft and ductile during process. So because it is at a higher temperature, the softness and ductility is there so that it can be easily molded, right? Right? No doubts, right? Here. So the application areas of hot working, right? The processes which involve hot working, we can say in one sense. Hot rolling, extrusion, forging, hot drawing, all these require the temperature, right? It requires certain temperature, and that temperature is what we are keeping as a reference to decide if it is hot working or cold working. So these all processes involve hot working, right? We have extrusion in our syllabus, forging as well. So upon taking the component to a particular temperature, you can basically sorry, either forge it or extrude it. So that is why they are linked, hot working and these processes. What I was talking about, extrusion, forging, hot drawing, etc. Hot rolling, just to give you an idea how, what is rolling and how it looks like. You have, as I said, change of this structure, grain structure. You can see how it is here and how it is here. Because of the deformation, the crystal, the grains have deformed, right? Recrystallized grain structure, you see, recrystallized grain temperature. So as it cools down, you may even have more, what do you call, difference of the grain structure. So that's hot rolling. So you see, this is a cross section, right? If you look at the components which are hot rolled, you will see that aluminum is hot rolled in this particular example into a coil of desired thickness. So that those are coming out, and there is this one is a coil of hot rolled steel, right? So we'll just go through what we call the basic understanding of these processes so that we can follow. There's the other processes which I said, other topics, they are helpful. Sorry. They're helpful to identify what type of process to go for, etc. Extrusion is a process used to create objects of a fixed cross-sectional profile, right? As you can see, hot extrusion is a hot working process above recrystallization temperature, right? So if you are saying it is hot extrusion, then it has to take into account the hot, what do you call, hot working guidelines, right? And because it is above recrystallization temperature, that's what is being highlighted. We are trying to extrude it, right? This is the RAM. This is your billet or starting material, which is being pushed through this RAM. And other thing would be you take a blank and then you try to force it in that die profile that he has done, and this blank will be converted into the final product, right? As for forging, simply stated, it's a manufacturing process involved in shaping of the metal using localized compressive forces, very high pressures. So only when you are trying to have more localized compressive force, then the process to go for is forging, right? Because at the periphery, if you want more strength, then your periphery should be good, right? It should be having that capability to take up those localized compressive forces, right? Many process types under forging. You have drop forging, press forging, roll forging, right? All these are there. As for hot drawing, I said it's a material working process which uses tensile forces to stretch material, isn't it? You're trying to stretch it from here, and therefore you're saying that it uses tensile forces, right? And it's used to stretch material. Hot drawing above recrystallization temperature. Okay, so yes, because this is under hot working or basically hot drawing, you have uh, under hot drawing, you will have that recrystallization taking place while it is subjected to that particular temperature. Various types of process material, bar drawing, tube drawing, wire drawing, right? Depends. So this is the basic drawing process for a metal bar, right? So it is taking the shape of the die cavity, right? The drawn bar. As for the advantages of hot working, hardness and ductility of metal is not changed. So the same hardness, maybe the same ductility, but it's not changed, right? Porosity is eliminated, right? Because you are trying to increase the temperature of the metal and therefore allowing it to stay at that particular temperature. And interaction with the other surrounding grain structure, right, will help us to eliminate porosity. As for grain structure of the metal, it is defined and physical properties are improved, right? The grain structure is now refined and physical properties are improved because of what do you call change of what do you call this? Because we are trying to have recrystallization, right? So that will improve the physical properties in the sense that there will not be residual stresses between the grains, and we can expect some uh, physical properties to improve. Large shape sizes are possible without ruptures, right? Because large shapes require more force and therefore they're possibly likely to rupture. How do you solve that problem? You are trying to uh, have this hot working concept so that even large shape changes are possible without ruptures. Smaller, faster acting machines, right? Because faster in the sense the metal is already having some higher temperature, right? And you just have to act fast and either form it or extrude it, etc. Impurities are broken up and distributed throughout material, right? So instead of having at one particular spot, it will be diffused in one sense. Surfaces need not be clean and skin free in this process because whatever is there with you is what is being corrected. So the surfaces even need not be clean and scale free. So that's not a problem. That's not working. It will just increase the temperature and then we can work on it. Right, we'll see the disadvantages so that we can finish off this hot working topic. Disadvantages: there is metal loss due to high temperature. A rapid oxidation or scale formation takes place during process. Right, so because of higher temperature, this is the most common problem. Oxidation, as we have heard, that there is formation of oxides or basically scales. So if it is to be removed, then you have to let go of some metal that will cost us, therefore metal loss. Weakening of surface due to metal loss, right? The metal has been scraped away, wear and tear, etc. So now you have weakening of surface because of that. This weakening may cause fatigue failures, right? Basically, fatigue failures are repeating, like tension and compression. You might have heard of this fatigue concept that upon subjecting it to repeated loads, the material will fail even before the predicted or what do you call failing load, right? Because of the fluctuating loads, the property, I'm sorry, um, the life of the component or the load bearing capacity of the component is affected. Close tolerances cannot be maintained in hot work because you're utilizing hot working at a high temperature. So therefore there is expansion, etc. Therefore you cannot go for close tolerances when it comes to hot work. High cost of cooling for some processes, right? High temperature and high energy consumption because the presses, etc. what are there, especially this big rams need to be moved with the higher power, right? So if either it is that high energy consumption or the high temperature also, because you have to employ furnaces, etc. to increase the temperature of the specimen or the workpiece. So therefore, you can say you have a high cost of cooling for some of the processes which require more energy consumption or more temperature. Right, so that completes your hot working. If there are any doubts, you can ask. Who is Sirisha? Not joined with roll number. Okay, then if there are no doubts, then we can close the meeting. Thank you.